So today we're going to be solving the week 3 chemistry AMS quiz, and let's begin. What's the oxidation number of an atom? An oxidation number is the fictitious charge that is assigned to every atom according to certain rules. This is the definition of the oxidation number. We must memorize it. You can't not memorize it. Now let's move on. In which of the following molecules does O have an oxidation number of -1? For this, we need to calculate for O. So let's start. Let's see. Here we have O2. This is an element. We said last week that elements always have an oxidation number of 0. Let's go here. H2O. So H2O. Now let's forget the fact that we know O is usually -2. And let's actually solve for it. So we know H is +1. Sorry, my mic cut off, never mind. So we said that H2 is +1. And since H2 is usually +1, unless it comes with metal hydride, which we're going to see in a question later, you count it as 1 and you multiply it by the subscript. So 2 plus something for O, which we're going to call X, gives us a charge of, the charge up here is 0. We don't have a charge, so equals 0. So 2 plus X equals 0, meaning X equals -2. So if X is -2, that means the oxidation number of oxygen here is -2, meaning it doesn't have an oxidation number of -1. Let's go on to the next one. Again, H2O2. We're going to assume H has, we know that H has +1. Multiplying it with the subscript gives you 2. Plus, we don't know O, but we know that we need to multiply whatever O is, aka X, by 2. So plus 2X equals, the overall charge is 0. Meaning 2 plus 2X equals 0, so 2X equals -2, making X equals -1. Meaning H2O2, the O here has an oxidation number of -1. CO2, we don't count CO2 because we don't even know what C is, what its oxidation number is. C's oxidation number is always to be determined, so we can't even look at this one. Na2O, let's look. So Na2O2. Now, Na is a group 1 metal. We said all group 1 metals have a oxidation number of +1. Again, +1 multiplied by 2, you get 2 plus 2 times X equals 0, meaning 2X equals -2, X equals -1. And these are the only two options where X, or aka O, has a oxidation number of -1. Moving on. Okay, so look, here we have electrolysis of molten NaCl. Now, we know that we have two sides for electrolysis. Anyways, the cathode and the anode. The cathode is the negative side that attracts cations, hence its name. So at the cathode, it's negative, but it's attracting the positive ones, and at the anode, you're attracting it's positive, but you're attracting the negative towards it. So we know Na is Na plus, and Cl is Cl minus. So anything to do with the positive one is gonna go towards the cathode, towards the cation one. And anything with negative charge, aka Cl, is going to go towards the anion one, the anode. So whenever you see cathode, it's the one that has a positive charge. And whenever you see anode, one with negative charge. Now let's move on. Okay, here you have HCl and it's added to lumps of CaCO3. What do you expect to get when you mix an acid with a calcium carbonate? We said when you mix any acid with any carbonate, bubbles are gonna form. That's one of your observations. Why? Because when you mix an acid with a carbonate, carbon dioxide and water are gonna form. That's your two answers, because look, acid plus carbonate, this is the net ionic equation, gives CO2 plus H2O. That's it. Memorize. So these two. Now let's move on. Here you need to calculate the oxidation numbers of aluminium in AlNO3 3. So AlNO3 3. What that means is we need to know, because here, take it as a, like, we had them memorized last year. Most of you forgot it, but NO3 actually has a charge alone of -1. All of NO3. So NO3 comes in one group and it's -1 of an oxidation number. So here you're multiplying this -1 by the 3, meaning you got -3 plus Al, aka X, gives you 0, making X equals 3. So the oxidation number of aluminium is 3. Now, it's asking you here, aluminium in its elemental state. We said all elements, their oxidation number is 0 in their elemental states. That's why it's 0. Now let's move on to the next question. Here we have HCl. Do you want the oxidation number of hydrogen? Here Cl is -1, so H must be +1, making it +1. Here O2 is H2O. We already calculated it in the first question, but O is -2. So 2 times 1 +1 gives you -2 equals 0. So this is true, making it also +1. Here H2 comes as an element. So if it's as an element, 0. Easy. Now let's move on. In a metal hydride, hydrogen has an oxidation number of -1. This is the exception for hydrogen. Whenever hydrogen comes in with metal hydrides, oxidation number becomes -1 instead of +1. To know what a metal hydride is just any metal like Ca with hydrogen beside it, without any O's, without any other things, just Ca and hydrogen, a metal and hydrogen. Here we need to calculate some oxidation numbers. NO2, we know that O is -2. Since it's -2, you're multiplying the -2 with the +2. So X -4 equals, charge is 0, so it's 0, making X equal to 4. And O is always -2, unless they ask you to specify when it's not. Now let's move on to the next one. HClO4. So HClO4. Here, what are the species we know? We know hydrogen, +1, so you put that down. We know oxygen, -2, so we put that down. Now let's find Cl. How do we find Cl? We put Cl down as X, add the hydrogens 1, and then you multiply this by the subscript, so it's -8 equals charge aka 0, so X equals 7, and that's Cl's oxidation number. So H is always 1, O is always -2, and we found Cl to be 7 in this case. Now let's find the last one. MnO4 minus. Now here we don't know Mn, so we write it down as X. We know O is -2, and then you multiply them, so -8 equals -1. So X equals 1, -1 plus 8, X equals 7 again. That's how you calculate for oxidation numbers. Now let's move on to the next question. Here we need to know how to find out if it's redox or not. So first of all, we're gonna find the charge we could use oxidation numbers, but here we can't because we don't know for Cu and we don't know for C. So we're just gonna use the fact that here you had O3, you had CO, and you had C. Here you still have Cu, we have O1, O2, and O3 all here. That's what you do when you don't have, what's it called? So here in your case, no oxygens were lost. You still have all three of your oxygens, so it's not redox. This is what you do when you can't find oxidation numbers. Now, let's go on to the next one. Here we can use our oxidation numbers. So O negative 2, so making equal to 0. So Zn would be 2 here. So in here, Zn's oxidation number is 2. Let's find it here. Here, Zn's oxidation number is, Cl is negative 1 multiplied by 2 is negative 2 equals 0. So X, and X would be equal to also 2. Let's find H. H is positive 1 always, right? Right. So positive 1 and Cl is negative 1. Cl here, we said it's negative 1. H is positive 1 here. O is negative 2. So as you can see, Zn stayed the same. Cl stayed the same. H stayed the same. O stayed the same. There was no change, so this is not a redox reaction. Now, let's see the next one. And either way, look, one oxygen here, one oxygen here. Your number of oxygens didn't change. Here, without looking at the numbers, you could tell this is a redox reaction because here you had 2 O's and here you had 1 O. Or, well, actually, never mind, you didn't. But anyways, here you have Cu as oxidation number 0. I prefer always using oxidation numbers. Cu as 0 because it's in an element. O2 is 0 also because it's in an elemental form. But here in a compound, O2 is negative 2 and Cu is positive 2 to make 0. So here their oxidation numbers did not stay the same. Since their oxidation numbers changed, that means it's a redox. Now here we don't even have oxygen, so we have to use oxidation numbers. Zn here is 0 because it's an element. H positive 1, Cl negative 1. Here Zn we take it because it's the only unknown species we know. Cl2 is negative 2, so x minus 2 equals 0, making x equal to 2. So that we don't even need to continue. Zn's oxidation number changed, making it redox reaction. Now, let's move on. Here, this question is really simple. You look at the charge up here. If it's plus 2, it's plus 2. If it's minus 2, minus 2. Minus means minus 1. Plus means plus 1. Okay, so the sum of all oxidation numbers, you have to look, is there a little tiny number in your corner? If there is no tiny number in your corner, the answer is 0. If there's a little number or like a little plus or minus, if it's plus or minus, it would be plus 1 or minus 1. If it's 2 plus or 3 plus or 4 plus, then it would be plus 2, 3 or 4. If it's negative 2 minus, 2, 3 minus, 4 minus, it would be negative 2, negative 3, negative 4. Moving on. Here, they're asking us which is the oxidized species in this reaction. Oxidized, we need to use oil and rig. So, what's oil? Oil means oxidation is loss, reduction is gain. So, when you look at the number of electrons, are electrons lost or gained? If electrons are lost, then it's oxidized. If electrons are gained, it's reduced. So let's look at our first species, CrO7 2 minus. What did it become, Cr? It became Cr3 plus. So Cr went from 2 minus to 3 plus. When a minus species loses electrons, what's it called? Wait. Okay, guys. So I left for a bit and I realized that if I use oil and rig here, I'm most likely going to confuse you. The easiest way to solve these types of questions is, look, you solve with oxidation numbers. So here, let's find the oxidation number of CrO7, specifically Cr. So Cr2O7 2 minus, so meaning O7, O, negative 2. Negative 2 times 7, negative 14. 2x minus negative 14 equals negative 2. So 2x equals 12x equals 6. And here Cr3 plus, 3 plus. So 3 plus meaning its oxidation number here is 3. So it went from 6 to 3, meaning it's reduced. That's why we don't choose CrO7. Now let's see K, it was 0. K became plus. So plus 1. O and plus 0 to plus 1 means it increased, means it got oxidized. So the one that's increasing is K. That's why we choose it. Now let's move on. Okay, so this is another memorizing one. The process of forcing an electric current into a system of chemicals, as a result of which chemical reactions that normally do not proceed spontaneously. Okay, I don't know how to read. Will proceed. It's called electrolysis. So, المهم, let's move on to the next question. Okay, here we're back to using the solubility rules. So to form a white precipitate, when you add potassium sulfate, so what that means is that it does not dissolve in sulfate. So it makes a precipitate with sulfate. Those are only, in the ones they gave us here, only 2 of them, which is barium and calcium. Those are the only 2 that they gave us that form a white precipitate or do not react with sulfate. Don't dissolve. White precipitate, when you add sodium chloride, Cl. Cl is a, what's it called? Halogen. Halogens, all of them, Cl, B, R, and I, do not, they all form precipitates with Ag. And like I said here, creamy, if it's white, it's Cl and Ag. If it's creamy, it's B, with Br is Ag also. So that's old material. Moving on. So, okay, lime water, milky, carbonates. Pungent smell, red litmus, blue, ammonium. These are the keywords. Whenever you see them, you know your answer. When heated with aluminium powder and the base, means nitrate, especially aluminium and heated. And choking odor upon addition of acid is sulfite. Now moving on. So here we need to solve using 10 over negative 14 over the concentration of H ions, which is, when they tell us pH, we know that 10 power negative, the pH is the concentration. So negative pH is your concentration. So meaning here our concentration is 10 power negative 5.36. When you put this all in your calculator, you're gonna get that it's 2.29 times 10 power negative 9. Now let's move on. Okay, here we have our oxides. Metal oxides, basic. Non-metal oxides, acidic. Metal oxides, basic. N2O, exception, it's neutral. CO is also an exception, it's neutral. ZNO, exception, it's amphoteric. S, not metal, oxide, acidic. Al2O3 is exception, it's amphoteric. Ca, which is a metal oxide, is basic. Now, let's move on. Last question. Here we also have to do that equation again. Concentration of H ions in, they want the H and the OH ions concentration. H2A, meaning you have to multiply the concentration of one H ion by 2, the subscript. So 0.400 times 2, you get 0.800. Now here for OH, you do 10 power negative 14 over the concentration of H ions, aka 0.800, and you get your answer. That's all for this quiz. Have a nice day. Bye.